So we have to find maximum possible speed of a car on banked road. Okay, so this is banked road. The road make an angle theta with the horizontal surface. Okay, this is the position of the car. Then mg force is acting downward. Mass into gravity is acting downward, and normal reactional force is acting perpendicular to the surface. Okay, and frictional force is acting along the surface of the road, and centripetal force is acting towards the center of the circle. Okay. This centripetal force is acting towards the center, of the circle. This is the centripetal force. Centripetal force we can calculate with the formula mv square by r. mv square by r is same as the centripetal force. Okay, so we have two forces here, one normal reactional force and frictional force we can consider. Okay, and mg force is acting downward direction. So we can find out the two components of the normal reactional force. So we can resolve with the x-axis and y-axis this normal reactional force. So this angle is theta, right? The road make an angle theta with the horizontal surface. Then this centripetal force and the surface is parallel. So this angle also theta by pair of alternative interior angle. Okay. Suppose this angle is theta, this one total is 90 degree, right? 90 degree. Then this angle is 90 minus theta. This angle is 90 minus theta. Then if we consider the y component of the normal reactional force, this angle also become theta. How it is obtained this angle theta? Because this is theta, this entire angle is 90 degree and the remaining angle is 90 minus theta. In the same way, this also 90 degree. Okay, so this is 90 minus theta, then this angle must be theta only. 90 minus theta become total 90 degree. Okay, so we have the one component of normal make with an angle theta with the y-axis. And the two component of the normal are, one is this one and another one is the is along the same as the centripetal force. This is the another one, same as this one. It's also one component of the normal reactional force. Okay, now we can consider a right angle triangle here. If you consider a right angle triangle here, this is 90 degree, right? So what is sine theta? Sine theta equal to, this is opposite side divided by hypotenuse. Hypotenuse is the normal reactional force. From this relation we can find opposite side. Opposite side equal to n sine theta. Okay, so this side is same as n sine theta. This vector, right? So this, if you move to the same as the centripetal force, this is also n sine theta. This opposite side is same as this along the direction of centripetal force. So this one also same as n sine theta. Okay, n sine theta. And a y component, y-axis means the adjacent side of this angle. Okay, this y-axis is adjacent side of this angle. So we can use the cos component. cos theta equal to adjacent side divided by hypotenuse. Hypotenuse is normal. So the adjacent side is n cos theta. Okay. So this one is n. This is same as n cos theta. This adjacent side is same as n cos theta. The same way we can resolve the two component of friction also, static friction. The two component of static friction are, one is along the x-axis, clear, right? One is along this x-axis and another one is along the y-axis. Okay, these are the two component of this frictional force. One is downward this y-axis and this along the x-axis. So in the same way we can find out a right angle triangle here. Right angle triangle here. This angle is theta only because it is pair of alternative angle. This one is Z pattern, right? So if this angle is theta, this one also theta. The same way, if we find the opposite side, we can use sine component. Clear, right? Sine theta equal to opposite side divided by hypotenuse. Hypotenuse is the side opposite to 90 degrees, the frictional force. So opposite side is same as F sine theta. And we can obtain the adjacent side. Adjacent side is, we can take cos component. Cos theta equal to adjacent side divided by hypotenuse is frictional force. From this relation, adjacent side equal to F cos theta. F cos theta. So this is the adjacent side. This adjacent side is same as F cos theta. And the opposite side, downward direction, it is this opposite side is F sine theta. F sine theta. This is same as, this opposite side is same as here also. F sine, it's a vector, we can move without altering the angle. Okay, it's also F sine theta. So from this relation, we can clearly observe that this centripetal force is provided by two factors. One factor is from the component of normal reactional force and another component is from the frictional force. Okay, so centripetal force is provided by one component of the normal force and one component of the frictional force. What are the two components? One is n sine theta and another one is F cos theta. These two force is providing the centripetal force. So we obtain a relation. Centripetal force, that is mv square by r, is provided by one of the component of normal reactional force, that is n sine theta, and the second factor, the one of the component of frictional static friction, that is F sine theta. Sorry, F cos theta. F cos theta. So we obtain a relation like this. Okay. So mv square by r equal to n sine theta plus F cos theta. At equilibrium, we can find that this mg and the downward force is F sine theta, both of them in downward direction, right? This mg and F sine theta is balanced with n cos theta, one of the component of normal reaction force. This component is balanced with F sine theta plus mg. So what you can write, at equilibrium, mg plus F sine theta is balanced with n cos theta. Okay, that is n cos theta is same as mg plus F sine theta. N cos theta equal to mg plus F sine theta. We obtain another relation. So we know that static friction Fs equal to mu s into normal reactional force. So this equation number 2 we can change. N cos theta equal to mg. Instead of F, we can write mu s into N sin theta. So we can transfer mu s into N sin theta to the left side. Then N cos theta minus mu s into N sin theta become mg. That is N into, N is common in both the term, right? So N we can take outside. N into cos theta minus mu s sin theta become mg. From this relation, normal reactional force N is same as mg divided by cos theta minus mu s sin theta. Now we can change the equation number 1. What is equation number 1? mv square by r equal to n sin theta plus f cos theta. We can change the first equation. Equation number 1 is same as mv square by r. Centripetal force is provided by one of the component of normal reactional force, that is n sin theta, and one of the component of frictional force is f cos theta. Okay, so f is same as mu s into n. So we can change this one. N sin theta plus f is equal to mu s into n. Mu s into n cos theta. We studied f is equal to mu s into n. You can substitute this here instead of f. Okay. Then now we obtain mv square by r equal to n sin theta plus mu s into n cos theta. So mv square by r equal to n we can take outside. So it will become n into sin theta plus mu s into cos theta. Now we can substitute the value of n, normal reaction force we obtained. So mv square by r equal to, what is the value of n? N is same as mg divided by cos theta minus mu s sin theta. So instead of n, we can write mg divided by cos theta minus mu s sin theta. Mu s sin theta into sin theta plus mu s cos theta. Sin theta plus mu s cos theta. So m and m we can cancel. Okay. So what is v square? V square equal to this r is cross multiply, it will reach the numerator. So r into g into sin theta plus mu s cos theta divided by cos theta minus mu s sin theta. Mu s sin theta. Now for making simplicity, we can divide numerator and denominator by cos theta. Dividing numerator and denominator by cos theta. So v square become r into g into, we can divide every term in the numerator and every term in the denominator by cos theta, and value does not change. Okay, so it will become sin theta by cos theta plus mu s cos theta by cos theta divided by cos theta by cos theta minus mu s sin theta by cos theta. So sin theta by cos theta is tan theta, cos theta by cos theta become 1. So it is reduced like this. V square equal to Rg into sin theta by cos theta is tan theta plus mu s into 1 is same as mu s divided by 1 minus mu s into tan theta. Okay, this is the so this is v square. So we can obtain by v by taking the square root, or all raised to 1 by 2. Square root of Rg into tan theta plus mu s divided by 1 minus mu s into tan theta. Okay, that is V maximum allowed speed in a banked road. V maximum equal to root of Rg into tan theta plus mu s is same as mu s in plus tan theta. Mu s plus tan theta divided by 1 minus mu s tan theta. This is the formula for maximum allowed velocity in a banked road. If mu s equal to 0, frictional coefficient, this one, static frictional coefficient mu s equal to 0. If mu s equal to 0, then optimal velocity V maximum become V max equal to root of, if mu s is equal to 0 means Rg into 0 plus tan theta. 0 plus tan theta is same as tan theta only. 1 minus mu s into tan theta, mu s is 0, 0 into tan theta, denominator become 1 minus 0, 1 only. Okay, so it become root of Rg into tan theta. Rg tan theta divided by 1, no use, because this is the formula V maximum if mu s equal to 0.